So what hackers want to do is they want to get inside of the guest partition. That's the first thing that they're going to go after, right? So they're going to go after the operating system that you're running on the machine. And then from the application, they're going to try to get into the OS. Now, in this case, we're showing the child partition on the right-hand side. So you've got a hacker. He's gotten a hold of through your application into your operating system, and from there, he's going to try to bust out any way and every way that he can. Okay. What we need to make sure that happens, what the hypervisor and the virtualization stack needs to do, is to make sure that the hacker can't get out of there. The way we do that is something called, we have to look at trust, okay? Because in this environment, we want to make sure, the key point that I want to make clear is the child partition is untrusted, okay? If we go to the next slide, this is what is trusted. Those things in the red box, those are the trusted platform. That means the parent partition trusts the hypervisor, and the hypervisor trusts the parent partition. Something you have to keep in mind, something you have to truly understand, is that in order to maintain that trust relationship, or in order to not jeopardize that trust relationship, it's just as important to keep the parent partition secured as it is the hypervisor. So be cautious about what you're running on the parent partition, because it is part of the trusted computing base, TCB. Yeah.
What's it calling that? Is that Active Directory or something else?
I actually have a slide on that, so let me come back to that, okay? So, what if there was no parent? Well, for starters, you'd have no defense in depth. The entire hypervisor would be running in the most privileged mode of the system. And you'd have all that bloat, all that stuff would be running in the hypervisor. You'd have your memory management, your scheduler, your network stack, your storage stack, your VM state machine, your virtualized devices, your drivers, your management API. You wouldn't have a thin hypervisor, you'd have a monumental hypervisor, you'd have a whole operating system. Okay, you defeat the purpose of a hypervisor. So instead, you move that stuff into a parent partition, and it further reduces the attack surface. So you get the stuff out of there and do the things in ring -1 that you have to do. Yeah, I said that wrong on the last slide. I think it's ring -1, not ring 0. Ring 0 is your operating system. The ring -1 is actually the hypervisor, and that's where you do the most critical things. That's where you do your scheduler, your memory management, those kinds of things. You do those core functions. You do those in the hypervisor where you need speed. You don't want to sacrifice performance. And get all the other stuff, the VM state machine, the virtualized devices, the management API, the storage stack, the network stack, the driver. Get all that stuff out of the hypervisor, put it in the parent partition, and let that partition run it. So you get optimal performance and optimum security out of that mode. So let's take a quick look at this. There are several slides of assumptions. Remember I said this was kind of a dry topic as we get deep in this? Am I going too deep on this stuff? Who says I'm going too deep? Okay, is this good stuff? You guys like hearing this? Okay. So, security assumptions. I'm going to talk a lot about trust here, because I talked about it a little bit, but guests are untrusted. We have to assume that bad things are happening in the guest. It's an assumption that we're taking, okay? The trust relationship, the parent must trust the hypervisor, the parent must be trusted by children. Okay, we haven't talked about that one yet. The parent must be trusted by children. That means, remember, because the parent is doing all that stuff with managing the drivers and stuff like that, so the guest must trust the parent. So you do have that one-way trust. The parent does not trust the guest, because the parent is part of the trusted platform, trusted computing platform. Code in the guest can run in all available processor modes, rings, and segments. Okay? Now, this is not really a security thing here. Okay? Code must be able to run in all rings, all segments. That's more of a performance thing. Okay? You don't want everything running in user mode, because then your performance on your guest machines would be deplorable at best. So we do want to have the assumption that code in the guest can run in all modes. The hypercall interface will be well documented and widely available to attackers. Remember, these are assumptions when creating the hypervisor. When Microsoft engineers set forth to replace virtual server, who used virtual server? 2005 R2? Okay. It was cool, but it was nothing like hypervisor is. It was a first step. Okay. And one of the things these are the assumptions that they had to take whenever they created it. The reason for this was they actually documented the entire hypervisor and published it on the internet in a public domain over a year before Hyper-V ever came out. Why? Anybody?
Get everyone off of 2005?
No. There you go. I wish I had a t-shirt to show you. Where are their vulnerabilities? Are there vulnerabilities in this? Because you know what? A lot of hackers probably tried to find them. A lot of hackers tried to find those vulnerabilities. So their assumption was, hey, once we design this, once we get this going, we're going to release it to the world. There's a couple reasons for doing that. Now that's the key reason, is they wanted to, if there was going to be exposed, they wanted to get it exposed before the product was actually out. But just as importantly, they want you to trust that, hey, you know, this is a secure environment, right? They want the government to trust that this is a secure platform. They want the military to trust that this is a secure platform. So it was a very, very important thing. All hypercalls can be attempted by the guest. So the guest can make calls to the hypervisor, okay? And the guest can detect that you are running on a hypervisor. What does that mean? Well, you know, first of all, how do you find out that you're running on a hypervisor? I mean, simple. Look at the motherboard manufacturer. Is the motherboard manufacturer Microsoft? Microsoft doesn't make motherboards. Really easy to tell you're running virtualized platform, okay? Now, some companies, whenever they create their virtualization, or whenever they create their virtualization, they would take the approach of security by obscurity. We're not going to tell you, you're not going to know it's going to be secure, right? Until something happens. And you find out, and now all of a sudden it's got this big giant gaping hole you could put a dolphin or even a whale through. So Microsoft didn't want to play that game. They wanted to make sure it was everything was done up front. The internal design of the hypervisor was well understood. People like yourselves, professionals in the industry, professionals in the security business, as well as hackers, are going to have access to this and really try to tear it apart. So some of their goals, based on those assumptions, some of their goals were this: strong isolation between partitions. Protect confidential integrity of guest data. Okay? Strong isolation between the partitions. One partition can't necessarily see what's going on in another partition. We'll talk more about some of the specific things that they did to make all these goals a reality, but that's coming up. Protect confidentiality and integrity of the guest data. One guest can't see the other guest data, etc., etc. Separation. Unique hypervisor resource pools per guest. Well, that actually gives us a bit of a performance hit, right? But what does it do from a security standpoint? Rock solid. Okay, so these were the goals. Unique hypervisor resource pools per guest. Yeah, it was a goal, and they did it for security in mind only, because there is a performance hit by doing that. Separate worker processors per guest. Again, all about security. Guest-to-parent communication over unique channels. Again, all about security. Okay. These were the goals whenever they created hypervisor. Non-interference. Guests cannot affect the contents of other guests, parent, or hypervisor. Guest computations protected from other guests. Guests can't look at memory and see what's in there if it's not their memory space. A guest can't look and see what's in the buffer for the CPU calls or whatever. The guest can't do any of that stuff and see what other things are doing. In fact, the guest isn't even going to know that there's necessarily another virtual machine running. Okay? We'll talk more about some of the other things that are done to keep this from happening. Guest-to-guest communications are not allowed through a VM interface. What the heck does that mean? Guest-to-guest communication not allowed through VM interfaces. Anybody know?